All right, well, you got a whole bunch of crazy going on here, and we're just going to have to keep track. We're going to bust through a bunch of these. G of 64 means we're going to refer to the G equation. We're going to plug in 64. Now, if you think about it, you take the sixth root of anything, it's going to get pretty darn small. You have a 64 that you're plugging in there. You're basically saying the sixth root of 64. Well, there's only one number that's so small. If you multiply it by itself 6 times, it's only 64. You guessed it. It's a 2. Okay. H of f of negative 3 means you're plugging, this is 2 problems in one. You're plugging negative 3 into the f equation. Okay. You plug it in, you cube it, you get a 27. Well, that's the output for f of negative 3. Now you're taking h and you're plugging in negative 27 into h. Okay. You do that, you're plugging it in here, you're basically saying h, well, negative 27. You're now going to raise that to the 4 over 2 power. Well, 4 over 2 is a pain in the neck. But 4 divided by 2 is 2. Not too big of a deal. But that basically means you're taking 27 and you're going to square it. Well, 27 squared happens to be, even negative 27 squared, happens to be 729. You go on to the next one. You've got a g of 4, f of g of 4, which means you're plugging 4 into the g equation. Well, that's crazy. You've got 4 now, and the sixth root of 4. Well, I don't know what that is. That's a bit of a crazy problem. However, you're going to take that information, plug it into f, which happens to be raising it to the 3rd power. Well, let's look closer at that. The 6th root and the 3rd power. Well, that's hard to do, but the 6th root can also be rewritten as the 1/6 power. If we remember that a root is a fractional exponent, well, now I can do something with this. This is 4 raised to the 1 over 6 raised to the 3 over 1. Well, wait a second, I can combine those. When you raise a power to another power, you multiply those two things together. And when you raise a power to another power, that then is a 4 to the 1/2 power. And if I remember correctly, I just did it back here. A fractional exponent is the same thing as a root. So this is asking me, what is the square root of 4? It's equal to 2. Oh yeah. Now, last one here, h of k of 1296. Well, again, we're taking that k problem. Well, again, this is our first time we're using k. But we're raising 1296 to the 1/4 power. I happen to know that the 4th root of 1296 is equal to 6. Take that information, you go back and you plug it into the h equation, where you're taking anything and raising it to the 4 over 2 power. Well, I'm taking 6 and I'm raising it to the 4 over 2, which is, again, a pain in the neck. But if we recognize that 4 over 2 is equal to 2, you got 6 squared, it's 36. We could just kind of go back here. What value of k of x is equal to 3? Well, let's go to the k of x equation. And let's say, well, I'm going to take 3 and I'm going to set it equal to the k of x equation, x to the 1/2 or 1/4. The one way that I can get that thing by itself, regular x, is to raise this thing to the 4th power. Well, I do that to both sides. X to the 1/4 to the 4th is equal to x. 3 to the 4th, that's equal to 81. Proof. Over here, h of f of 64. Well, we're basically taking the 64 and big picture, we're setting it equal to the h equation. Okay? So if you're doing that temporarily at least, you're going to say that x to the 4/2 is equal to 64, or x to the 2nd power. So if I raise that whole thing to the 2 over 1, well, 2 over 4, I guess, is what it would be. So this is confusing enough, remembering that we can reduce that completely. The 2 over 4 power is the same thing as the 1/2 power, and 64 to the 1/2 power is equal to 8. So now I've got 8, but that's not my solution. That's just to the h of x part. Now I got to take the 8 and set it equal to the f of x equation. And the f of x equation happens to be x to the 3rd power. So take 8, set it equal to x to the third power. We take the third root, or the raised to the 1/3 power. Third root of 8, 2. Now that's a whole lot of crazy.